how can I join your funny company?
You are welcome to come anywhere.
I'm welcome. Thank you. Thank you. Not really. Okay, we have another restriction. All other guys in the competition have a time limit, and we know why we set a time limitation. They have 8 minutes to purr a lot, and after 7 minutes you will hear a sound like this. Okay, we can do that all together. Which is the sound after 7 minutes? These are very hungry cats. What? They have to hear it in front of all of you. So, again, what's the sound after 7 minutes? Very good. And Daniel, show us the sound for final. So are here some cats that are able to imitate this final sound at 8 minutes? What is this here in the Institut für Chemie? Okay. You're going to stay here. Good. Now's the last chance to move. We say hello to our first slammer in the competition with a big applause. Please welcome Moritz.
Okay, welcome everybody. My name is Moritz, as you can see. And one of the most frequently asked questions of family and friends is, what are you actually doing during your PhD and what it is good for? So the task for today's presentation was, how can I explain my research to non-chemists? And that's difficult because that is my research. So normally I'm starting with the catalyst because you can compare it to cars and it's a funny little yellow powder and you can shine light on it and then it does chemistry. But when I'm finishing explaining all this, my presentation would be over and I haven't even started with my research. So what else can I talk about? I can talk about the starting material. You all know it, it's coffee. You know it from the coffee. Some people perhaps know it from a special shampoo which is supposed to prevent you from losing your hair. But who actually believes that coffee and a shampoo prevents you from losing your hair? Well, I don't know either. What I know is Henry Musker, he did some commercials in the 90s for Alpecin, and I saw a couple of years later his last fight, and he looked like that. So, perhaps you choose for yourself if it's working. So perhaps with my method, we can make it better, the coffee. We can put fluoride groups at it. The truth is, I don't really know if it's better. I haven't put it on my hair, I haven't tasted it and checked whether I'm awake for a week or something. So what it's all about, my research. To explain this for non-chemists, I have to start a little bit more basic with a periodic table. So these are all the elements we have in the world. And I'm an organic chemist. And organic chemists, they deal only with these few elements which are marked, which you can see there. But why is there such a big research area dealing with such few elements? Well, because you can use these elements actually a little bit like Lego. You can connect them and build up bigger structures. And so, for example, all organic matter, humans, plants, they are they are almost completely out of these elements. A simple example, a little Lego airplane if you want, is this one. You all know this, it's ethanol. You're perhaps looking forward to have some this evening. And this is the structure of ethanol. As a chemist we would draw more like that, because we are lazy when it comes to drawings. We leave out the carbon and the hydrogens. And then this really makes sense, you can see at these structures, because it's more like big Lego castles or something. And you also know these. So when I'm drinking some of this ethanol this evening, I probably need these two, vitamin C and aspirin. Probably I won't consume these two, but you all know them, morphine and nicotine. Some of you perhaps recognize already the last one. Some of you perhaps already consumed it, for health reasons of course. It's THC, so the active substance in cannabis. Here's another one. It's fluoxetine. It's sold as Prozac. It's an antidepressant, and it's prescribed over 24 million times every year, only in the US. And it has this structure you can see there. But how can we synthesize such a structure as chemists? Well, to explain this, LIGO is a little bit too simple, because chemistry is sometimes a little bit more complicated. And as I can tell you, if the reactions are not working, it's also much more frustrating. So, well, let's compare with IKEA furniture. So, what are you doing if you want to have such an IKEA chair? Well, you go to IKEA and you get little pieces. And that's exactly what we are doing, need as chemists. We need little pieces of this structure. What else do we need? We need an instruction how to build up this chair. But chemistry is still a little bit more complicated, because when it comes to bigger structures like the morphine you've already seen, then it's a little bit more like building up a complete IKEA kitchen. So you need plenty of instructions for all the furniture in this kitchen. And what actually has to be in such an instruction? So to explain this, I want to come back to my first reaction I showed you already. So you need, of course, the little pieces, the substrates. Then you need some additives to bring all together, which are consumed to fix all together. You need a tool somehow, that's a catalyst, which you can use again, and which makes your work much faster and much more efficient. You need some energy, that's normally us, building up this chair. And what else do you need? You need a solvent. It's basically a liquid that provides a nice environment for the reaction to work. So, to construct a chair, I would choose some beer for it. So, with this, I made some instruction for the fluorination of coffee during my research. But I already told you I don't know really what it is, what it's good for, the coffee. But fortunately, reaction often works with similar structures. So there's a variety. You see the caffeine, and all these molecules you can see here, they have some similarity to the caffeine structure. So all these molecules or compounds you can fluorinate with my reaction. So I made a more general instruction for fluorinating certain kinds of structural motifs which you can find in different kinds of compounds. And what do we do with such an instruction? Well, we're writing a publication, it comes into a database, and the next time someone wants to build a kitchen, he perhaps finds my instruction, and perhaps it's very useful for his research. But why are such fluorinating groups and molecules so useful? To explain this, I want to show you some compounds which are all produced on ton scale every year and which belong to the most sold chemicals in the world. So you have the Prozac, I've already showed you, as well as some pharmaceuticals where are treated in prostate cancer, and an herbicide and a pesticide. In fact, 20% of all pharmaceuticals contain fluorine groups, and even up to 40% of all agrochemicals contain fluorine groups. So somehow it seems that these fluorine groups provide a better activity for molecules provide a better activity for organisms. So, fortunately, I'm already at the summary. I thought I had less time. So I did fluorinated coffee, and I don't know really what it's good for. Perhaps Henry Musker would have been much happier to have fluorinated coffee in his shop with a look like this in his last slide. What I know is that I did an instruction which is very useful for future researchers to fluorinate certain kinds of structural motifs which you can find in a database and which is really efficient and useful. So with that, I want to thank you all, and have much fun with all the other slammers. I'm pretty sure that
Thank you, Moritz. Usually the competitors have some words in front of them. With me, it's okay. I don't care. Okay. Like everything of that what you showed us today. Some kind of Prozac or
yeah.
okay, whatever they give you.